Welcome to Kubernetes SIG Apps for Monday, October 21st, 2019. Hello, everyone, and I will drop the agenda into the chat here. We've got a few discussion points, but we don't have any announcements or a demo. Did anybody have any announcements to make to start this off? All right, silence means not. And then if nobody's got a demo, we'll jump right into the discussion. The first one is the CAP for the resource type for the common applications. Here, I'll drop a, oh, no, that's the wrong link. We drop the link in. I actually thought this may be worked on elsewhere, but as I dug into more of it, it doesn't look like it is. I'll drop the link in over here. This is something that I had originally proposed. The general idea is there's a bunch of different ways to get at services. You can use something like the service catalog. You can, if you go to the operator framework, there is now the operator SDK that's been proposed. They have a system for essentially bringing on services. It works really similar to the service catalog. You can handle things like there's a controller for an operator for chargebacks. And so you can essentially stand up services in your cluster. But of course, everywhere you go, you get a different interface to work with those, which makes it kind of hard to specify and then share all over the place if you're into sharing your applications. And so that's where this was born out of. I thought there was some more work done to try to create a common interface on top of it, but I haven't found a whole lot on it. I was actually hoping to mark this as overcome or withdrawn, but I don't know that it can because it hasn't been solved. And I also, but I'm the one who proposed it, expecting to work on it, and I'm not going to have any time to work on it in the near future that I'm aware of. So I didn't know how we should handle it. Should we leave it sitting there as provisional? Should we withdraw it for the time being? Anybody have any thoughts on this?
Matt, I remember there was some overlap with, I think, what Crossplane were doing regarding this. I'm not sure if that was one of the reasons why we didn't move forward on this.
That was part of it. Did they end up going with the cross? That was the one I couldn't remember. Thank you.
So the other thing that, and I don't know if it solves the exact same problem. I have to reach out to like Sunil, Sali, and some of the guys who are currently Red Hatters and IBM and formerly Core OSers who are working the operator SDK. But there's some work to kind of converge operator SDK, not just to use controller runtime and controller tools, but to actually have Kubi Builder and operator SDK do the same thing. And part of that conversation was like either extending or creating something that would be effectively application metadata for controllers, I guess is the way you might think of it, to kind of complement the application CRD and then try to converge on some common sets of metadata that can be used across the community for all these things. Janet might know more about what's going on with it presently, to be honest, but that was kind of why I was just like, I didn't really have a whole lot of interest in it at that time.
Yeah, so I'd be curious to know what's going on with Operator SDK and Kubi Builder. The Operator SDK has been submitted to the CNCF TOC for a candidate for incubation. There's an open pull request on it. And I think they wanted to add in the Operator Lifecycle Manager, which appears to be very similar to the service catalog. Granted, it's built entirely differently. It's using the modern controllers, CRDs, and all of that. It's not using its own API gateway or anything like that. And so that's where I'm wondering what will happen with the two, if they're going to converge or not.
I mean, they're working to so the metadata piece, like OLM exposes a notion of subscriptions and channels to pull things in, and then it has effectively a catalog of its own. The common metadata is really so that that becomes an open kind of standard, and primarily with Operator Hub being like a multi-company supported open source kind of discovery portal for operators, we want everyone to be able to consume them, not just OpenShift users. So that was kind of where we're going with it. But yeah, I mean, like, so there is like a notion of it getting badged to support like particular cluster configurations, but being able to consume it and not having like a standard for how the metadata should be consumed is kind of, it makes it very hard for other people to write tooling that is directly interoperable with Operator Hub. So that was kind of the problem they're trying to solve.
Well, with Operator Hub and the Operator Lifecycle Manager, it looks a lot like a service catalog and not other ways you may use operators. And that's one of the, I've been asking questions and I haven't gotten a good answer on it yet. But I'm trying to, what if I've just got one application and I'm basically taking my run books and turning them into an operator, and I'm not standing up many, many services. I know there are people who are using this case. And so how does that fit in with something like OLM? And I haven't gotten a good answer on it yet. And nor what would that would mean for the Operator Hub. Is it only using certain use cases? I'd love to know if somebody has those details.
I could try to reach out to them and see if they'll come and talk about it.
Okay. They may also be the CNCF SIG app delivery. It's probably going to come up in there because they're charged with that kind of stuff. And so if they want to get into the CNCF, it'll have to go through that group first. So I imagine it'll come up there too. But yeah, if they were interested in coming over here and talking, I'd be curious, especially one of the things that I've been interested in is how do you manage your CRDs in a cluster? Like what kinds of patterns do you use, especially when you have to deal with things like updates and differences and changes? Because they're solving some of that with OLM, I'd love to hear their take on it. Okay. I'll look back at Crossplane, see how it's doing, and maybe dig more into OLM on this. I didn't see how it made it easier to specify, though, in a selection of manifests, which you're going to use. And maybe I'll have to go dig more into that. Okay. That's what I had for that one. The next one we have is the agenda for the KubeCon deep dive. Ken or Janet, I know this is yours talk. You want to take this?
Yeah, I just wanted to bring it up to anybody who's here and see if they're, get talking about if there are any topics either you can send to the mailing list or post to this doc that we want to be prepared to discuss. We were kind of thinking that what we would try to do is set the agenda at this KubeCon for what we want to try to accomplish over the next like 2 quarters and discuss that. But if there's anything of particular interest, we'd like to know so we can kind of be prepared to talk to that or drive a conversation around that. So.
All right, silence may means folks don't have, if you have any ideas or things you want to hear, please bring them to the mailing list then, or email Ken and Janet. The next one we have is the cluster scoped application CRD. Barney, I think this is yours. Are you on?
Hey, yes, that's mine. I'm just going to, yeah, I have the link in chat. Oh, it's on the doc as well. I just updated it. So we have been getting feedback from some internal users of application CRD that there is a gap when it comes to representing objects across namespaces and also cluster scope namespaces objects. So we feel that introducing a new cluster level construct would be useful, and we can call it cluster application. Sorry, cluster scoped application CRD. We can call it cluster application, but maybe we can come up with a more generic name than application. This is a more overarching change for this application CRD project. I just wanted to discuss and see if it makes sense. Like, can we call it stack, or can we call it something else that captures the notion of something more than an application?
So maybe let me ask this. What's the role of the person who would be installing and working with this? And what kind of application or what kind of stack or thing would they be installing, managing, and watching?
Okay, so today, application CRD provides the ability to soft link resources together so that you can have, you can get status of all the resources that are referred in the application CRD. But we could extend this down the line. So it is more of a representative object, which is a collection of already deployed or something that's deployed independent of application CRD. It's an object that will refer to all of these other resources. In terms of management, it does not do anything more than just collect the status of those resources.
Yeah, and what I'm kind of actually looking at is if we broke it into different roles, what kind of role would the person be who's doing this, and what are they doing? So and what kind of application would they want to do it with, or what kind of workload? Because it seems like application is very much for the application operator, right? Not the person who's trying to run cluster scope services, or they're not a cluster admin. They're saying, hey, I want to run an application. And so to run an application, say, we'll use WordPress because everybody always does WordPress examples, right? You're going to want to run that as a namespace application. You're an application operator who's focused on that. If you're dealing with, different people who are dealing with your cluster and you've got separations of concerns, it might be one set of people who make sure the cluster runs and another set of people who run the applications, right? They're kind of different roles here. And so it's very easy to be namespaced in this, but it does have certain features that sound really great for other cases, like a collection. And in my understanding, maybe it's not an application operator to do cluster scoped. It's maybe somebody who's trying to do a different role and they're trying to run something cluster wide. I'm just trying to grapple with what this means and where you'd want to go with it.
Got it. Okay. So one of the trigger points for this discussion was the resources that they were installing. So the marketplace is something that's using it. So there were some users who wanted to tie CRD definition and then RBAC, cluster level RBAC rules to the application. So when you install, all those get installed, and when you delete the application, all of them get cleaned up. Which is the use case, which is one of the use cases that came up. But granted that CRD management can be done differently, but there are some RBAC rules, cluster level RBAC rules that are tied to the life cycle of the application. It's mostly useful in a self-service marketplace kind of environment rather than a proper a cluster which has different administrators.
Okay, so this is, you want to maybe install an application, and not only are you tracking the application's, deployments, stateful sets, those kinds of things, but also some of the objects that have to do with standing that up in general.
Yeah.
Yeah, so like the RBAC configuration that would be installed for it. Okay.
Or
so,
like
hello, Matt.
Oh, sorry.
Hi. I was wondering if I could contribute to this part of the conversation. You all haven't met me. This is my first time joining you all. My name is Chris Vignola. I've actually part of a small team that's been using the application CRD for a little while. And I just wanted to ask if a use case that's relevant to this conversation about cluster scope application CRD might be one of the ones that we've been wrestling with. We've been wrestling with a use case where we have customers who are modeling applications, cloud native style applications. So a set of microservices collaborating, right? You know, a web UI or a mobile front end or what have you as the user interface. They have different teams building and deploying these various microservices, as is rather common. And some of the services they have, in fact, they view as shared services. And they want to deploy them out, and they want to reuse the live deployments across multiple applications. And so what we had is is a case where some parts of what the user views as their application are in, you know, are in one namespace, you know, their principal namespace containing most of their microservices and their UI. But there's another microservice in a different namespace that represents a shared service. And that same shared service is used by some other set of applications as well. And the user wants to view not only the microservices and UI that they deployed, but this shared service as well as part of their view of the application, because they want to take into account the status of all of those components taken together as their view and understanding of their application. And so we were wondering about that, you know, applications comprised of parts that are deployed across multiple namespaces. We didn't see that as an obvious part of the current consideration in the application CRD. And so we're wondering if that's a use case that you guys view as valid and if it has anything to do with this conversation.
Can I ask a question?
Certainly.
So for the application that's being consumed from another namespace by multiple services that reside in, let's say you've got some database, right? Like MariaDB, right? And then you have multiple services connecting to MariaDB. And MariaDB is in a namespace managed by like MariaDB admins. Why wouldn't the kind of way we usually think about that is if the consumers have the capability to view it, then they would get read permissions for that namespace. Maybe not write, but read permissions, right? So they would be able to see that application across namespaces via just their view permissions. And then like for something like that, because the application isn't packaged together, like the life cycle of the application isn't tightly coupled. It's very loosely coupled. Generally what we see is that they're integrated via sharing coordinates. So for instance, accessing that database or accessing that microservice would be done via like a Kubernetes service, right? Or by some other mechanism of sharing the IP address or FQDN that allows you to attach to the application. And the status of the application is really, it's not kind of, it doesn't aggregate up, right? Because it's very loosely coupled. That's kind of how we thought of it. But is that sufficient for what you guys are doing, or is that counterintuitive for you?
I would not say counterintuitive. I'm not certain that it's sufficient for what we're looking at. We have a case, for example, we have a case where there's a credit score service, and it's being used from two different, from two different applications. Each application is a set of deployments, a UI, some other microservices, and a use of the credit score microservice. So credit score we have like two such applications. So you say you have app 1 and app 2 deployed to namespace app 1 and app 2. Each app 1 and app 2 is a web UI and a collection of microservices deployed to the App1 and App2 namespaces respectively. Both App1 and App2 both share, make use of, and therefore share the credit score microservice in the credit score namespace. It's managed by a separate team. And in the application CR for App1 and App2, each of those teams would like to define their component kinds and their label selector in such a way as they have soft links to not only the things that they've deployed into their App1 and App2 namespace, but also soft link reaches out to the credit score microservice in its namespace. And that's the thing we weren't quite sure, what is, the recommended approach for, applying the label selector beyond the namespace of the application, the namespace in which the application CR itself resides.
And so I can kind of see where this could have some usefulness, right? Because if you're going to go construct a UI, the application CR would then have everything you need to even trace off to dependent services by other teams. And if you've got read access, you can actually view what's going on with those. And even if something's maybe having a problem right now, so you can trace problems in your application and you could visualize that with the UI, right?
But garbage collection will give you a bad time if you have soft links and cyclic dependencies.
Yes. So that's exactly what I wanted to. So we did run into issues where when we referred cluster scope resources in the application object, garbage collection went ahead and randomly deleted things. So we don't know a way of, we can reject those in the application controller, but this needs to be documented. And that's the reason why we want cluster CR, especially for these use cases.
Ken, do you have any other thoughts on this? I don't know enough I'd have to go do some investigation on it. I haven't thought of it this way.
I mean, like, if it's something you guys want to experiment with, and there are obviously people who are somewhat interested, I would say propose it and let's, go forward with it. I don't see a problem. Like, the entire purpose behind like SIG sponsored subcon projects and so forth, assuming that like you and Anand and Janet and like the other people in the SIG don't disagree with it, is to let people go off and iterate and try new things. And we can always turn it down if it's not useful, my opinion. The one thing that I would be kind of interested in though is converging, because like there is the notion of cluster scope CRs that manage like many instances of an application or so forth. Like there's convergence there with some of the stuff that OLM CRs have. So it would be cool to me to see if like we can work with the Red Hat guys or CoreOS guys or whatever, and gals, whatever their current team is, and see if we can't come up with something that's common and can be shared by multiple projects. That'd be my only like feedback.
No, I like that. The other thing that comes to mind is I think I heard something in there about managing CRDs.
Right.
And I think that gets complicated, especially if you've got more than one controller and using shared informers. Because, if you say you got two controllers looking for a CRD and one of them goes away, what happens to the other one? And how do you know at what level to manage these things?
Do you mean two controllers like during an upgrade, or two controllers where you have like multiple controllers each watching separate namespaces?
Well, let's say you've got two controllers watching separate namespaces and you go and remove one of the things. I think it was, removing CRDs. And so you go and delete a CRD from a cluster, and then you still got another controller in another namespace that's expecting it. Now the CRD is gone.
Yeah.
And that's some of the work. Go ahead, Barney. Sorry.
Yeah, you're sorry to interrupt. So Matt, that's true. That'll only work in the case of singleton applications. We don't have a notion of singleton application entirely in Kubernetes. This was used by a team where they would install a controller, and then that's the only cluster scope controller on the cluster, and then individual teams would install CRs and in individual namespaces. So when the operator is deleting this controller, this package, it means it'll clean up everything in all the namespaces. That's the expected behavior.
Yeah, I understand that. I'm actually thinking of one of the applications being installed. Install CRDs.
Okay.
And say you have 2 instances of that application and you remove one of them and it goes to clean up that CRD, the other instance that's still running is going to break.
Yes. So that's why I said it is only useful for singleton applications where you install.
Okay. Yeah, it's only useful for singleton. And so how do we mark that and capture that and make sure those things?
We don't have a way of defining and doing it clearly.
Yeah.
It's tough, but one of the use cases, like if you've ever turned up like Istio, for instance, like I could see it being useful in that use case, or even managing the life cycle of something like Istio. We're basically, go ahead. Sorry.
Yeah, the team that came up was Kubeflow. Go ahead, sorry.
Yeah, or Kubeflow. Things where effectively you're installing a lot of things at cluster scope that are going to be shared. And like this is a similar case to what was being described previously when you have multiple deployments across namespaces and dependencies. The hard part is like, like with Istio, you get like, if you have, I mean, some things are optional, but generally, you know, you need Pilot. If you're doing secrets, you need SDS or Citadel. You need all of the CRs that are associated with those. You need the mixer. So you have everything or nothing, right? And either you install it all and you have a working system, or you don't. So in those use cases, it's kind of clear and straightforward. When you have things where it's like, I have 2 services that depend on a third, and the 2 front ones, you know, I could have like I can delete one and it's entirely independent of the lifecycle of the other, but they both need a third. That's really hard to express using any of the tooling I've seen in the ecosystem so far, including application CRD and probably even cluster scopes if it's not thought through very carefully.
Okay. But yeah, I would love to see an experiment on trying to make this work. I'd be curious to see what it looks like. Okay. Are there any other questions on this? Anybody have anything else to discuss on it? Can y'all hear me?
Yes.
Okay. Well, if that's it, that's all we had for the scheduled discussion. So now we can have any open discussion. Were there any other topics that folks wanted to talk about?
So actually, yes, Matt. I put it into the proposed topics section of the agenda. There's this Microsoft and I think Alibaba are collaborating on something they call the open application model. I was wondering if you guys have seen that and what you think of it. It's interesting, but I'm not sure what it means to the application CRD that you guys have been defining, whether it matters, whether it looks like another way to achieve what the application CRD is.
Yeah, so I did look at it, Barney here. I just wanted to get, the notion of application that Alibaba and Microsoft built is a deployable object, and it is not tied to Kubernetes. It's more of a portable definition that will work across Kubernetes and function as a service platform. So it is different from application CR, like it's not trying to be a collection of objects, but more of artifacts that can be deployed. And they are building a controller which will translate the specification into Kubernetes, set of Kubernetes resources. So it's different in the way it's approaching packaging and how you represent applications definitions.
Also,
Yeah.
Bernie, I have a question, and you might not know. I couldn't figure this out. How does it? So, like, okay, you've got that, and then you've got CNAB as well, right? Is it completely separate from CNAB, or does it tie into CNAB as well?
It is different from CNAB. CNAB is more of the physical package, right? And this is more of a spec. So I do see where this can be bundled in a CNAB. That's how I see it. This
Yeah,
is more
think of
yeah.
Yeah, I was just going to say CNAB is kind of like a common way of bundling things up. Helm does TGZ files, right? CNAB kind of says, okay, if you're going to run something, you need a common packaging. Here's the packaging. With the open app model, I went and I actually got Matt Butcher, the lead developer on that, on the phone the day it was launched, right? Because I was going to poke his brain on it. And I haven't looked at it much. But one of the things that I noticed is that it gives you, so if you're going to go deploy production WordPress into a cluster, you need about 13 Kubernetes resources to do so. And that doesn't actually get you pod disruption budgets or auto scaling either, right? So you can actually add more than those 13 resources. That's a lot for somebody to need to know and to configure. Especially if the person who's going to do the pod disruption budget's an operator, and that may be different than somebody who knows the application that's going in. If you've got big companies where you actually have those as separate roles, the person who knows the application versus the person who's going to stand it up and operate it. I understand lots of people try and drive away from that, and I've worked at enough companies to know that you can't always get the organization to do that. But their idea here is you've got a definition for what you're going to run, and then somebody can go run it, and then they can layer on traits that'll do things like auto scaling if they know it needs to be auto scaled. And the idea is it's also a simpler definition. You're not going to get everything that you get in Kubernetes. You might get, I'm guessing 80% coverage. This is just my quick look on it, or 70% coverage of what people need. But those edge cases that I've only run into a couple of times, and I'm glad it's there, you may not get those from it, right? And so it gives you that different experience in onboarding and doing all that stuff.
Yeah, so it's more of a boiled ocean approach, right? Like instead of writing Kubernetes YAML, you write a completely new spec. And the traits were interesting. That is something that you can layer on top of. That's something the operator can layer on top of the application definition.
Yeah, in Kubernetes YAML at this point, I'm learning that the amount you have to learn is becoming difficult to onboard. I took the Kubernetes API spec for Kubernetes 1.13, and I said, let's print this to a PDF. I want to see how many pages it'll be, 8.5 by 11. And then I thought my computer broke because it took so long to generate it. If I just scoped it down to just things I might need to run workloads, it comes out over 1,100 pages printed. And that's not any of the guides or anything. That's just, our spec is huge. The amount of knowledge, and I mean, just to run WordPress with a database, it's, at a production level, you're talking 13 or more different Kubernetes resources, manifests you got to install. That's not small. That's complicated. And so there are folks out there now working to try and figure out how do you ease that knowledge and onboarding. Go has this idea, you want to fit the whole language in your head, right? You kind of can't do that with Kubernetes, even when you're going to go do manifest and this, if your primary job is maybe just working on the business logic. How do you make that simpler?
I think one of the main problems that I've seen for users of Kubernetes, like the most basic things you can do to get something running are actually not that complicated. But to get it, like you said, running in a production state and to fully leverage the features that the platform gives you, it gets complicated. But I can't, I've experimented so far with Helm and Customize together, Customize independently, and Customize for last mile customization on top of the Helm charts. A little bit of CNAB, just like so many things. And ultimately what it comes down to is when you get to the point of it breaking in production, if you don't understand the YAML, you're hosed anyway, right? Like if you can't interface with the system via kubectl or via some other mechanism to expect the API machinery and understand what your declared state is and understand where the system is with respect to realizing that declared state, you're really not in a good place. And then the overhead, like there are some things that like Helm, for instance, is really good at lowering the overhead for onboarding for deployment. Like you just do Helm install, Helm release, like simple couple sets of commands. If you have this package is already there for you, and getting it up and running is a lot easier. CNAB was like super complicated. At least that was the feedback I was given. But at the end of the day, when you're trying to troubleshoot, or if something does go wrong, or if there's unexplained behavior, like tracing back an alarm that triggers a page or a flappy monitor to what's actually going on in the cluster, that's like the hardest cognitive dissonance to get over. And whenever you like create a separation from the YAML, it makes it even harder. And now you've got somebody who's like, well, I just did Helm install. I have no idea what, like, it made a deployment maybe, like.
Yeah, and some of this gets into some of the differences, right? Like I've done apt-get install MySQL or apt-get install Postgres so many times, right? And I don't need to know the layout of Debian or every file and everything about that application to do it. And I can just get it, right? And it works pretty solidly. But if I had to go troubleshoot it, it's now going to be a little bit more of a pain in the butt. And that's what package management does. It takes somebody who knows both the operating system and the application and can bring the two together so somebody who doesn't have all that expertise can go and install it. That's package management in a nutshell. And so that's what you get in Helm. But if you're going to go run a bunch of your own applications, when do you wrap it up and in a package and then distribute it? I've worked at companies where we've deployed our applications using, Debian packages and apt. And I've worked at other companies who say, okay, we'll do some of our dependencies that way, but we're not going to do our own bespoke application that way. We're going to do some other things in it. And yeah, you've got to know a bit to go troubleshoot that. But if you've got a project with 300, 400, 500 or more developers on it, how many of them need to be able to deal with something lightweight versus have to know all of that depth? And it's when you scale up in these enterprise companies and the number of people who are working on something and how much knowledge do you need them to go learn all of this stuff about Kubernetes? Well, they're probably going to forget it because they don't touch it very often. It's the people who are close to the Kubernetes work and troubleshooting who will know it. But those people who are further away in the business logic, how much do they need to know in order to be effective, right? If you're a small team, it's different than these organizations. I mean, I've worked with projects that had 500 engineers working on them or more. And that still boggles my mind how you can have something with that many people on it. But who needs to know how much stuff in order to be effective on it?
So like for me, it's looking at it like this. Like I'm trying to reduce my R&D spend with something like Helm or with a package manager so that, once I get people across the board, it's easy for them to package their stuff up and deploy it. And they don't have to spend a lot of time on it, right? Mm-hmm. But most of a large portion of my spend is actually going to go toward OpEx, right? And like if the thing that I deploy increases my OpEx budget, or worse, cuts into the revenue because I'm in the middle of an outage and it turns into a production whodunit, didn't help, right? Like, yeah, like R&D, I spend it up once to get something deployed, and then there's an ongoing kind of like BAU effort to continually patch it and upgrade it. But the OpEx, that's a constant spend. So I don't have, other than like the conclusion that I'm coming to is like, there's really, like if people don't understand, because if you're building a package and you don't understand the Kubernetes primitives that you need to deploy, you can't do it. And then once the package is deployed, if you don't understand what it actually did, you can't troubleshoot it. So I just haven't been successful in like elevating people above YAML.
So let me put it this way though, right? So basically Heroku and Cloud Foundry, Cloud Foundry's working to get Kubernetes as a backend. You can deploy an application with a much simpler YAML file, right, and some code, and then it does the rest. And they don't know the Kubernetes primitives, right, or the primitives to Diego, which is what Cloud Foundry has long used. And I'm not sure where Heroku is in their things these days, and so I'm not going to speculate. But if you read where they're going, you can speculate for yourself. And they don't need to know all of that complexity that they have to have in their lighter weight definitions. And it's made not everybody, but a whole lot of people successful while needing to onboard and know a lot less, right?
And I would add that like OpenShift tries to do the same thing with Kubernetes by providing a PaaS on top of it. Mm-hmm. And then Pinterest, if you've looked at what they've done recently, they basically built a PaaS on top of all the Kubernetes primitives using custom resources. So I think I do see a proliferation of PaaSes that try to like, I'm going to take the institutional knowledge to orchestrate Kubernetes and encode it in a set of controllers that meet the workflows that my teams actually use. And that's where I'm going to spend my money. And then as people, you know, like when you onboard, you just create Pinterest service or Pinterest cron job. And all the other intricacies about like interfacing with the rest of the platform will be handled for you. Right? They're basically, Cruise is doing something similar. There are just very many PaaSes out there, and maybe that is using CRDs to build a PaaS on top of Kubernetes is the best way to go. I don't know.
I don't know, but I don't know how good the open app model is, quite frankly. I haven't had time to sit down, look at it, and play with it and pick it apart yet to find what I like and don't like about it. But I kind of understand why they're going into this space and just the business problems in the space. Does that help, by the way, all of this? Who originally asked this? Chris, did this help with your question and your point on it? Was this where you wanted to go?
Yeah, somewhat. I really just wanted to see what your, what your reaction was to it. I couldn't quite discern whether it was an alternative to the application CRD or a layer, an abstraction layer that potentially sits above it.
It would be an abstraction layer that sits above it. And one of the things it could do is generate an application CR. If that were installed or part of it, it could do something like that, but it is a layer above it.
Yep. Yep. And that point of view is very helpful. So I thank you guys for the discussion around that.
Okay. Well, thank you for bringing that up. Do we have any other open discussion topics for today?
It's more to do with the mechanics around application CRD. So we don't have for the SIG sponsored projects, we don't have KEPs, right? It's mostly open issues or how, if you have to brainstorm some ideas, should it always be through this or can be just open issues or design issues? I don't know how we should do that.
So because this is a sub-project of Kubernetes, we're not required to do CRDs. And I don't know if we want to change this, but at least the last time we talked about it, the idea was, hey, we can be lightweight and more fluid and just use issues, unless we see a need to bump up to something more formal like KEPs. But so far, we've just kind of decided, hey, we can do this lightweight and issues and talk about it there, if that's acceptable to people.
That makes sense. Yeah. So maybe a design doc where we can capture more information than in issues and then link it to the issue.
Sure, that sounds great. Well, our idea of not doing more complicated was just to keep it lightweight and fluid.
Got it. That makes sense.
Okay. Do we have anything else? Going once, twice, three times. Thank you, everyone, for coming. We'll be back here in 2 weeks. Everyone have a wonderful 2 weeks. Thanks.
Thanks all. Bye.